A 79-kilogram student rides a lift up to the top floor of an office block. During the journey, the lift accelerates upwards at 1.26 meters per second squared before traveling at a constant velocity of 3.78 meters per second, and then finally decelerating at 1.89 meters per second squared. Calculate the apparent weight of the student in the first part of the journey while accelerating upwards at 1.26 meters per second squared. All right, first thing, let's draw a diagram. There's our lift, there's our student. We are accelerating upwards at 1.26 meters per second squared. So therefore, the net force on our student we can get from Newton's second law. Okay, or if we want to write this properly, F net is ma. Okay, F net equals ma. So, our mass of our student is 79 kilograms. Excuse me. So, 79 multiplied by 1.26. And so the net force is going to be, thank you very much, 99.5 newtons. Okay, going back to that previous slide and that equation, we have F net equals Fn plus Fg, which we want to find Fn here. If we're looking for apparent weight, we need Fn. So let's rearrange. Fn is equal to Fg minus F net. Now we need to be a little bit careful about directions. In which direction is our net force going? Upwards. We're accelerating upwards, so F net is up. What about Fg? Down. Fg, what about Fn? It's got to be up. Yep, Fn is the force from the surface, so it'll be from the floor. Okay, so let's count upwards as positive. So F net and Fn are both positive. Fg is negative. So, I'm going to have a negative in there. All right. So, our Fg is, what did we say Fg was? Oh, we didn't. So 79 multiplied by 9.8. Minus 99.5. Sorry, 774?
Yeah, 0.2.
Yep. 99.5. No, hang on. Yeah, it's minus, so we need to add those. You're right. Yep. So I get 873.7. Okay, so you can see in this, our normal gravitational force that this student would experience is 774.2. They are currently experiencing 873.7. So they will feel heavier than normal, which makes sense. We're accelerating upwards. Okay. B. Calculate the apparent weight of the student in the second part of the journey while travelling at a constant speed of 3.78 meters per second. Per second. So, we can do this the long way, but you should be aware that the apparent weight is going, if you're not accelerating, Fn is just going to be equal to Fg. However, let's do it the long way. F net is equal to Fn plus Fg. Okay? Our net force is equal to those two. Now, if we're not accelerating, what's our net force? 0. So our net force is 0 equals Fn plus Fg. So there, aside from our sign convention, Fn is going to be equal to Fg. You can chuck a minus in there if we like. All right. Fg, 79 multiplied by 9.8, 774.2. Okay, that one's nice and easy. Last one. Calculate the apparent weight of the student in the last part of the journey while they are travelling upwards and decelerating at 1.89 meters per second squared. All right, so again, we draw our force arrows here. Fg is down. Which way is Fn? Normal force. Still up, it's still the floor pushing on them. And what about Fnet? Down. We're decelerating upwards, so the net force has to be down. So Fnet is going to be equal to 79 multiplied by 1.89. $149.3. Okay, there's our net force. So again, from our Fg plus Fn. Now, let's still take up to be positive, just because it makes sense that way. So that means Fg and Fnet are both negative. So that's negative. That's negative. So that means, if we rearrange that, Fn is going to be equal to, add Fg to both sides, Fg minus Fnet. Okay, so just rearranging that equation gives us, we worked out Fg before, 774.2, minus our Fnet, 149.3, 624.9. And again, as you'd expect, if you're decelerating, you would feel lighter. If you imagine yourself in a lift, as you're decelerating, sorry? Up is still positive. Yep, as you're decelerating, you would expect to feel lighter.